Hey guys, this is Prestige Motorsports again. We're going to do a quick video on how to wire up a car and how we go about initially determining what we're going to do, new harness and everything like that. One of the first steps we do is just take the old existing harness in the car, untape it, unloom it, things of that nature. Look at all the wiring, see if there's any type of melted wiring, if somebody has been into the harness prior, which cars of this era, usually that has been done, and determine whether you just need a whole new harness or are able to use the existing harness. This particular build here, a 69 Charger, we determined that the harness was in pretty bad shape, had some big bulkhead connectors that had been melted and things of that nature, so opted to go with a new harness. So once that's decided, you can just kind of go over what systems you're going to be having in the car, whether it be EFI, stuff of that like that, what type of ignition system, heat and air, power windows, just the list goes on and on. Once you have all those things figured out, you can kind of get a count on the number of circuits and that you would need to know to get your new harness. They have all kinds, from the basic circuits all the way to ones with power windows, heat, AC, EFI, endless options. So once you figure that out, you can go ahead and lay out all your systems. Like here, this particular build, we have a Dakota digital gauge cluster. All that was mounted prior to the harness even being into the car. Consider fuse block location. I don't know if you can see in the video, we do have ECU for the fuel injection down in there, and determine where you're going to put all those. That kind of has a big effect on how you're going to route the wiring and everything like that. And this can take anywhere from 1 or 2 days. Planning is everything when it comes to wiring. A lot of it can even be done outside the car. It's way easier to heat shrink and solder everything when it's outside the vehicle. You can get a very good idea once you have all these systems laid out in the vehicle of what your harness is going to look like, and just makes the installation a lot smoother to think those things out and be able to determine where all that goes. We heat shrink, solder and heat shrink every connection, just not wire to wire, but also spade terminals like this. You can see it's soldered, then heat shrinked over the whole spade terminal, just to prevent any types of problems like that. And, just everything is planned out to where when you go to run wire, you know what everything needs. Even every system, determine if it needs ground, what type of power, straight from the battery, or can you jump off the fuse block? Does it what type of signals does it need, like an ECU for instance, for fuel injection, RPM, key on, that sort of things. What relays need to be ran in the car, what doesn't need to be on a relay, what needs to be on switches. All that can be, a lot of those wires can be ran in the harness outside of the vehicle, which makes it tremendously easier rather than having to be on your back or be upside down trying to twist wires and solder stuff together. Hope this helps. Thanks for watching. Alright, now let's look at a few soldering tips and techniques that we like to use here at Prestige, and a few that we don't. Take a look down here. We got your, here's a typical insulated butt connector. Problem with these, you can see this one is over crimped here, leaving exposed metal, and sometimes they don't hold well and they can pull out. You can't solder them together for a good connection. Here's a non-insulated one. I'd say these are a step above the insulated. You can give a better visual inspection, and you can dab some solder in there for a better connection. Here's a couple without a butt connector. Some people choose to do this just because it's easier to grab the wires like this. They're bare here, just twist them together real quick, put some solder on it. The problem with this is And then you fold it over like that to lengthen your wire, and it gets a little bulky there. Added stress to the wire, real tight bend like that. We don't like this, none of these here. And here's one that we typically use, but if you can really get in close and look at this one's just had too much heat during the soldering process. If you look back here, it doesn't bend. The solder is wicked back up into the wire underneath the insulation. Here, if your guy's using this, you definitely need to find a new guy. We would never do anything like this, so we'll throw that one out. And here's one that is a good connection. What we typically do here, you can see that just enough heat to melt the solder. Just about 3 dabs of solder. It's still pliable underneath the insulation and everything, and slide some heat shrink over it just like that, and just looks like a continuation of the wire. Another thing we like to do when we're wiring up Dakota Digital, stuff like that, when we bare our wire, Dakota Digital box uses a clamp that clamps the wire. If you just dab a little bit of solder on the end of the wire, it helps to get the wire in there and clamp on it really well, versus something like this that's, you know, you're going to try to get it in there, it's just going to fray apart or smash flat when you do clamp down on it. Here, let's take a look at some ring terminals and spade terminals. Here again is an insulated one. Like we said before, you can't really inspect it to make sure you got a good connection and everything, and if you do have to bend the wire over here, there again you have some exposed wire which can lead to a short or something of that nature. These are a little better here for our spade terminals. You know, here you can't do any solder work or anything like that, and these can be hard to pull apart, which can lead to you pulling the wire all out of the connector in disassembly or whatnot. And here's another insulated ring terminal that something we don't typically like to use. This here is what we usually do with spade terminals. Here you can mechanically crimp the wire so it's good, you know, can't pull it out, and then you can solder it. And then we also put the heat shrink here, just allows for more protection. And same with our ring terminals, you know, a crimp with solder there, and then heat shrink over it.
Come on.
Alright, now here are a couple different battery lugs. You can see this one is a closed in. If we were to use this type of lug, basically you slide your wire in there, you can fill it with solder, let it cool, and then you can come back and stake it to give you that mechanical grip that these typically have. And here's one where you could see a lot of guys would either take a pair of vice grips, smash this flat, or put it in a vice, something like that, and that just leaves you with an odd shape. As you know, it just kind of flattens out, way wider here on the wire. Here's what we typically do, is just a crimp style like that. As you can see, it's just more same size as the wire. Once you heat shrink everything, it all just looks better in appearance. And here's all the basic tools you need. Just a pair of wire strippers and crimpers, different style crimpers here, some weather pack stuff like this, and then as far as soldering, good rosin core solder helps a lot. And then there's 2 ways to do the solder. You can use like a propane or butane torch. This works exceptionally well. It's very quick. You just click it down, and about 1 to 2 seconds you have heat to solder your material, whereas the torch can be a little cumbersome. If it's in tight quarters, you can burn other wires, stuff like that. So